We are tasked to solve for this given differential equation, but the process that we are tasked here is actually the use of the idea of linear equation. And for us to do that, we need to understand first the integrating factor that will be used in our processes. To solve for the integrating factor, we simply need to identify these two different functions, p of x, f of x. And by the way, we don't need yet f of x. We just need p of x, but these two will be identified by our first process in looking for the integrating factor. The point here is we are going to first identify whether our given function is in standard form. The standard form is given as the first order derivative of y with respect to x plus p of x of y, p of x rather, is equal to f of x. Once we can establish the standard form, we can determine f of x, and we can also determine p of x. But of course, it should be in a standard form. So that would mean, looking at our given, we have here x squared, and therefore it's not yet in standard form. What should be done in order for us to make sure that it's in standard form? The goal here is try to multiply with 1 over x squared on all terms, so that in our first term, we only have dy over dx. What happens then is as you go to your second term, that's x over x squared, you're expected to have 1 over x of y. And for your right-hand side, that's simply 1 times the item you're multiplying, you have 1 over x squared. As compared to the original given, this is now in its standard form, because you can see here a function on x. That means that's your f of x, 1 over x squared. We may not be using it right now for our integrating factor, but we'll be using that on a future process. And this would be what corresponds to your p of x. Your p of x here is 1 over x. Why do we need to do this? Because our integrating factor expressed as mu sub x is identified as e raised to the power of the integral p of x dx. This factor will be used later on in further solving this equation together with f of x. So we will have a separate video for that. But for the integrating factor, let's continue. This e to the power of the integral of 1 over x is our p of x dx. So simply take the integral of our exponent. So you will have here, if you don't know the integral of 1 over x, that's actually e to the power of natural logarithm of the absolute value of x plus c. But you may not need plus c here because the integrating factor only looks for the appropriate exponent. This can be further written as the e raised to the power of the natural logarithm of simply your x. This can be simplified further, and that would mean that our integrating factor is just simply this value, which is x. This is our mu of x. Please take note of this, because on our separate video, which will be focusing on the process of solution of this given equation, we will be using this integrating factor together with f of x. But for this video is concerned, we started with making sure that our equation is in standard form. Then we identified p of x together with f of x. Then we used p of x for our integrating factor. Thank you very much for watching.